Okay, we're doing 9.1 and this is, we have 2 more examples to do. We're supposed to solve this problem using completing the square. The first step of completing the square is to get the variables on one side and the numbers on the other, and make sure that your variables are written in descending order. So we're going to have 4x squared minus 10x, and we're going to take and subtract the 11 to the other side. Minus 11. So minus 11, 0 minus 11 is minus 11, right? So then the second step is to divide every term by the lead coefficient, which in this case we have one, so we're going to divide everybody by 4. And simplify. So this is x squared minus 5 halves equals negative 11 fourths. Then you have to find the new c, and there's a formula for the new c. The new c equals b squared divided by 2 squared. In this case, our b is negative 5 halves. So this is negative 5 halves divided by 2 quantity squared. Now if you do negative 5 halves divided by 2, that's negative 5 over 4. So this is negative 5 over 4, and you can use your calculator to verify that if you needed to. So our new c is equal to 25 over 16, because 5 squared is 25, 4 squared is 16, and a negative squared is a positive. So that doesn't look like a 16, but I'm going to make it look more 16-ish. So I'm going to add 25 over 16 right here. And I'm going to add 25 over 16 over here. Got to add the new c to both sides. Now what the new c should make is it should make this factor. And if you're thinking, well, how does that factor? Well, good news is it tells you right there. It's negative 5 over 4 times negative 5 over 4. So you can verify that when you do negative 5 over 4 times negative 5 over 4, that you get positive 25 over 16. And when you add these together, that would be 10 over 4, negative 10 over 4. And when you reduce it, you get 5 halves. So this thing becomes x minus 5 over 4. So that's kind of clever that it tells you right there, right before you squared it, how it will factor, which is a negative 5 over 4 quantity squared equals whatever this is, right? I'm going to use my calculator to figure it out. And you could do it by hand. You could say I need a common denominator and all of that business. That'd be great. So divided by 4 there, and plus 25 over 16. So that's negative 19 over 16. So I'm going to take the square root, use the square root principle that we've been learning, right? It said that when we have something like this equals either a positive number or a negative number, not a variable though, this is going to be that x equals plus or minus the square root of k. In this case, our k is negative 19 over 16. So this is, and in this case, our x, this is the capital X, it's an algebraic expression, x minus 5 fourths. So we're going to have here x minus 5 fourths equals plus or minus, there's the plus or minus, the square root of negative 19 over 16. And I want to reduce that, and the square root of a negative is I, and the square root of 19 doesn't reduce, but the square root of 16 is over 4, right? Because this is in the denominator. So this is x equals negative 5 over 4. Oops, I didn't mean to do that. X minus 5 over 4, I meant, equals plus or minus, and I'm going to pull out the I and the 4, and that's going to be the square root of 19. So lots of different ways that you could write that. How I've written it is okay, but you could also write it as I square root of 19 over 4, and that would be great too. And many books would write that as a square root of 19 I over 4. It's becoming more popular to put the I in the front, and I'm good with either, and at this moment in my life cannot remember what our book does. I can look there, but however you want to write that, this or this is just great. I'm going to add 5 over 4. 5 over 4 is not like terms though with the I or the square root of 19, so it's just going to go right here in the front, 5 over 4. So this is going to, when I add it, so this is going to be x, I'm going to add it here too, right? It's going to go over there. So I'm going to have 5 over 4 plus or minus, and I'm going to write it like this, I square root of 19 over 4. And if you wanted, they have a common denominator of 4, and you could put it together if you wanted as 5 plus or minus I square root of 19 over 4. That's the same. Both are good. Wonderful. We did a lovely job. We have one more problem to do. And that's this problem about Fermat's last theorem. And so it says, as mentioned in the previous chapter, the postage stamp shows Fermat's last theorem, which states that if n is an integer greater than 2, then there is no positive integers x, y, and z that will make the formula x to the n plus y to the n equal z to the n true. Use the formula to find z if n is 2. So if n is 2, you can find it, but if n is some value greater than 2, you can't find it. And so if I asked you to solve x to the third plus y to the third equals z to the third, find 3 values that would make this true. Well, 0, 1, and 0. Positive integers x, y, and z that will make the formula this true. Oh, my washing machine is saying we're having trouble with our washing machine. It's really sad. And so anyway, so they're asking us to solve. I found an answer. 0, 1, and 1 over there, but I think they're meaning other than trivial answers. And so not 0 and 1. If you have 0 and 1, you can almost make anything true, seems like. And so here, this is going to be 6, right? Because this is x to the n plus y to the n equals z to the n. And they said n is 2 and x is 6, so 6 to the second plus 8 to the second equals z to the second. And we've solved things like that, right, when we were using the Pythagorean theorem, right? So this is 6 squared plus 8 squared equals 100, equals z squared. And so you can use, so we have z squared equals 100, and you could use the property that we've learned in this section, right? It was x squared, that's how they wrote it with x, equals k. And they said that that would mean that x equals plus or minus the square root of k. In this case, that's going to be z equals plus or minus the square root of 100. And the square root of 100 is 10. So z equals plus or minus 10. So we did a good job on that. And again, they have n is 2. They're asking us to find y. So this is x squared is 5 squared plus y squared equals 13 squared. So this is 25 plus y squared equals 169. And taking away 25 gives us y squared equals 169 take away 25 is 144. And then using this property, right? So y equals plus or minus the square root of this of 144. So y equals plus or minus, and the square root of 144 happens to be 12. So there's 2 answers for that one as well. So we did a lovely job on part 2 of this 9.1, and so that's it for chapter 9.1.